So welcome everybody to the SafeXtend webinar. Hopefully everybody can see my presentation on screen, so please drop a note in the chat if that's not the case. The SafeXtend project is an Innovate UK funded project which started a year ago, and we are due to finish at the end of this month. So this webinar is really to showcase all the research and development work that has taken place in the past year. If people who are in the meeting wouldn't mind please remaining with their microphones off and cameras off just during the process of the meeting, because we've got a number of videos to share which will take up quite a bit of bandwidth. We are not muting everybody automatically, so it's part of the question and answer session at the end. Everybody will be invited to, if they wish to, put their cameras on, or otherwise to speak directly with the team. So the agenda for today is an introduction, very brief introduction, which will be followed by some project videos given by our partners. There will also be a live demonstration. Everything, fingers crossed, that will all work on bandwidth okay. And then finally a question and answer session. So by way of introduction, SafeXtend is an AI-powered VR training platform which has been invented to meet the skills training needs in the construction industry. Its objectives originally were set out as 3D scanning of the construction sites to then produce AI-driven scenarios for the training to be played through a VR-based simulation. The intent is for customized learning experience, which then allows us to help the construction users to improve and adapt their training as they go along. So in summary, it's a lifelike, interactive, site-specific training simulator that can be used in any construction environment. I'm going to stop sharing my screen now and shall hand over to Paul.
Okay, thank you, Kate. Pleasure to be on the webinar this morning. I'm just going to share my screen, and then the intention is to deliver some and demonstrate some of the outputs that we've achieved through the project. So let me just share here. Sorry, bear with me. Okay. And is that sharing okay? Okay.
Yeah, that's good, Paul.
Brilliant. Yeah, so as I say, this is the second webinar we've delivered. The initial one probably went into a bit more of the technical side, the deliverables and how we were actually achieving. This one is more focused on what we've achieved, and yeah, share a few videos. I think the vast majority of the webinar will be sharing videos, images, and I believe there's maybe got about 10 minutes, 10 to 15 minutes at the end for a Q&A session. So this initial slide just talks about the approach that we took. So as Kate mentioned, the initial delivery of the project, we went out and we identified numerous sites. We then took a LiDAR scanning and photogrammetry and 3D imaging capture via a variety of methods. And then ultimately we've ended up with two VR modules. On the left, Tricor, that's where I'm from. And what we did is we scanned a lot of sites actually, but the one that we progressed with in terms of the VR build was a house building site. This site was based in Ireland. It was a great example of a sort of generic house building site, lots of hazards, lots of vehicles, scaffolding. So it was perfect one for us to develop. And yeah, as I say, we took it through from LiDAR. We then did point cloud to mesh to Unreal, and you'll see the logo in the bottom corner. We developed the training platform in Unreal. On the right hand side, you can see an example of the VLab training, and now this again, similar concept, taking actual data and taking that all the way through to VR training. But as part of the project, we looked at different processes, different ways of capturing the data, and different ways of building VR. So that one predominantly focused on using the LiDAR, which we captured using a drone, and then using also a lot of 360 imaging to generate a virtual reality terrain environment in Unity. So quite exciting. Two very different approaches, and maybe at the end we can discuss about the pros and cons of each route. But yeah, we've got some nice videos to share. So output. In terms of what we've got here, I'm going to show a video. I'm not going to share my sound, and I'm just going to talk through this whilst this is sharing. So this is basically a very high-level overview of the environment that we scanned. As I say, this was a construction environment. This is generally within about 20 millimeters of reality from what we scanned, and it was a great example of a generic site. As I say, you had lots of activity, you had working at heights hazards, you had tripping hazards, you had lots of traffic, you had pedestrian routes. So what you're seeing here, and hopefully it's sharing fairly well, it's very smooth on my screen, but I know it's sometimes limited over Zoom. But this is the site, and you would be able to walk onto that site. Obviously, it's very different now because this was scanned some months ago, but a very good representation of what that site was like at that time. And you'll see within here, I'm going to do a live demonstration after I've been through the videos. But what we've tried to do is look at generic hazards and then integrate training within that. So this is a cinematic view that you're seeing at the moment, which is just to give you an immersion of the environment. But the user can pick up a VR headset, access the site, enter the site, and then be given specific training relating to that site. So as an example, what you're seeing on the screen here is almost like a cabin. When you're in the previous life, I was a quantity surveyor and spent a lot of time on site. You will usually be inducted. You will have you'll go through obviously risk assessment method statement, and then you will be provided information about how to remain safe on that site. So here we've done examples of integrating PPE training. So here the user can walk in there, find out what PPE is required, select it, find out more information about that specific PPE and why that's required. Again, this could be lifted up and put into numerous environments. Here we did a bit of research and focused on key hazards. So here you can see users working at heights, for example. They are not physically, virtually climbing a ladder. They then press their I button, and we've used the interface in there all the way through the VR module so that people can, once they've done one activity once, they understand how the process works. But in the background, you have a voiceover providing detailed information about the hazard, how it can be mitigated. But interestingly, one major benefit of VR is in terms of knowledge retention is actually undertaking those actions. So here we have a manual handling exercise. We've also integrated some quite cool stuff in terms of fire. Mentioned earlier about the route of traffic and avoiding collisions, segregation on site. So that should give you an initial introduction to what we've actually achieved. So how do we do it? Well, in terms of the data capture for this specific site, which was actually over in Ireland, we looked at the feasibility of various sites. I mean, we scanned a lot of sites. We scanned sort of steel portal frame buildings. We scanned construction sites, the pole climbing site that you'll see that VLab will share shortly. But we picked one that would be representative of many hazards on construction sites. Once we've been through the feasibility, we captured the point cloud and imagery by a variety of methods. We used BLK equipment, we used Matterport equipment, we used mobile equipment, we used drones, and the outputs for that were a variety of photogrammetry, point cloud data, which is captured by the LiDAR, still images, video footage, and 360 images. And we then took, and I'll show a very quick example here, which hopefully looks something like the site that you've just been looking at there. So you'll see here, this is a photogrammetry output, but whilst we captured that obviously behind this sits a lot of the LiDAR data. You can see from here, there's it's typical of a generic house building site. Lots of material, lots of excavation, scaffolding, working at heights, and the hazards, material storage, etc. So what we the actual VR model that we've built, as I say, is highly representative of that. We did clean out some of the roof trusses, etc., to make the navigation through the site a bit simpler. But hopefully you can see from these images, it does look a lot like what we scanned. Well, it should do anyway. So following on from that, once that data had been captured, there was a bit of a cleansing process and reviewing the data that we captured and trying to make that as real as possible. Now we worked one of the other partners on the project, Brunel. Once we'd taken that point cloud data, that was handed over, and they worked on an algorithm to basically convert point cloud data to mesh, and that was integrated within the module in certain areas. There was issues with some of the outputs. I mean, it was a very advanced way of looking at it, but once we took the outputs, there was certain almost depth added to certain areas, and you can see here we did refine that utilizing a variety of software packages, such as Blender, to try and make that more usable, if you like, in Unreal and basically detailing the textures. But yeah, as I say, exciting part of the project, this one, and we use a variety of software to eventually get. Point cloud came in. We used sort of recap, Cyclone 360, Terra. We did like a matrix of point cloud. The algorithm didn't perform particularly well on large areas or less dense point cloud, but this is that was part of the project. And as I say, we once we were reasonably happy with it. That was then moved into Unreal, where we then did the development. So briefly conscious of the time, and I do want to get into this live demo. So very important, I think, to explain why it's important. Why do you need this? And we, certainly don't see VR solutions replacing physical training, but it's definitely got its role to play. And I think a sort of blended learning approach is something which, well, it is being adopted already. The benefits with health and safety in terms of immersion, getting people into an environment, experiencing it remotely, scalability. There's lots of opportunity there. Even we've done previous projects on assets that aren't even built, so you can scan an area, you can then put and build something that is going to be there, and people can understand that from a planning and design perspective. There's lots of opportunities outside health and safety, estimating, tendering, etc. But this project specifically focused on hazards, and that's what we've done. We've looked at a lot of research on what the hazards are, how they're addressed, and as I say, hopefully in the live demonstration, which is hopefully going to share very well over Zoom, you'll get the idea. And just before I do that, in terms of feedback, as part of the project, we have been doing testing. It's been good. It's been positive. My view is certainly been very, generally speaking, maybe the younger generation that have been brought up on VR computers literally need zero training within this, which is quite exciting. People are getting more and more used to it, and I think it's moving away from a gimmicky. This is quite cool to actually adding value to operations. Okay, so I'm just going to stop sharing my screen on here, and I'm going to try my best to share a live demo within the VR. So just bear with me. Okay. Right? Everyone can hear me? So here, I have my fingers. I can look around here. Navigate around the area, played around with different weather. Here I have my hands. If I was walking and had a large enough area, I would be able to navigate through that. You'll see being able to share treadmill. I'm in ladders. See here all the silhouettes we've got here, the information side, provide further information. For example, looking at height and objects, also have barriers, have demarcation, poles, etc. Okay, so turn that off. No, if it's okay, I'll go back. Okay, so hopefully that shared relatively well over the visual. I'm not sure if the sound was coming through, but if I now go into here, you will see a summary of the training. So here you can see obviously, to access the site, you decide whether you're an operative, whether you're a site-based, and the training has been adjusted to factor for different people delivering, going on site as a whatever role to reflect, their requirements. Once you go into this area, you will see. We'll go into it. You'll navigate around, and I showed this earlier. You can go into the PPE. Within there, you can learn about the requirements, why you need the PPE, ensure that you've been, validate it by ticking the button and validate the fact that you've understood that. Quite cool on the right-hand side, you can see the point cloud data, which is what we scanned. So we sort of integrated that within the model just to give a bit of an overview of the site. And I'm going to skip through this to get to some of the training sections. So here, you'll see, and as I say, all the way through the VR module, we've integrated the same actions and processes. So that I will bring up a prompt, a virtual screen. It will, in the background, you have a voice giving an overview of explaining what's going on, why you're doing it, asking you to do certain activity, demarcation. So, for example, here, placing the barriers all the way at the side of the thing would be a good way to keep pedestrian routes away from heavy vehicle traffic. You will then go through and explain, that you've understood that exercise. The training continues, and hopefully, I believe it goes on to the working at heights next, which again, I think anything within VR where you are utilizing the equipment to its best potential. So yes, you can watch a video. You can sit there, you can understand it. This could all be a video, but the fact that the user is navigating around the site, they're pressing a button, they're understanding it, they've been explained, what the hazard is, they're reading it, but then the physical actual movement of lifting items up, moving it around, it's, in terms of retention, and this is what I was referring to earlier, where we were talking about the blended learning. There's always going to be a place for the physical training, but I think the fact that if you did a training module such as this before you attended site, you would have a much better idea of the layout, a much better idea of the hazards. And then once you're in there, you're starting with a basic level of understanding before you've even done that. Here, this is what I was talking about, what I've just demonstrated live. So you can climb the ladder. You will then be same process as before. Touch the eye. That will give you information, so say background talk through what's going on, what you need to do. And again, we've tried to list out the sort of key items so that the user can actually do the exercise, but then they can actually press and almost validate, verify that they've actually done the activity, they've understood it. And as I say, anything that's going to benefit the sort of health and safety process, even if it was supplementary, is we believe is a positive thing. Over the far side over there in the background, you can see the pile of blocks. Again, certain things like manual handling. And we also, after this, it goes into a fire scenario. Now, again, when I was talking earlier about the benefits of utilizing the technology, you've got to play to its strengths. So yes, we've all been on fire training where you can physically pull the pin out and practice with the extinguisher. However, generally speaking, the fire that you're targeting will be a small, in a tray, it would be a controlled small fire. Now, within this environment, you can have the ability to experience something much more extreme. And again, the emotional response that the user might have, how they deal with it. There's the ability to actually pick up the wrong item to deal with the hazard and see the consequences of that. Now, that's not integrated in here, but what we're saying is there's the ability there to use the technology to its strengths and experience stuff. And it might be if you do something wrong, that emotional response will perhaps support it not happening again in the future. I am conscious of time. See again, other things that we've done in here, we've played around with weather. You'll see certain sections where it's like snowy. Again, we put some mountains, etc. in the background, but we've had it where it can be sunny, it can be dark, it can be light, it can be windy. There's a lot of cool stuff that we can do to make this a bit more unique as opposed to your standard rigid linear training that's exactly the same every time. There is the ability to play around with the environment. I'll get to the fire one and then I'm going to close on my section, so again, prompts, information, visuals, videos, anything you want within there. We've tried a lot of different methods to get the information across to the user. Here you go. There's an example. Now, if we wanted an explosion, if we wanted that's to start getting out of control. Again, it's that immersion and putting through the prompts. Is it manageable? Can we deal with that ourselves? If not, you could have different size fires. So it's the ability to experience lots of different scenarios in there is where we feel the strengths come from. Now, I appreciate that was a lot, and I hope that shared okay, and it hasn't been very skippy, but happy to take some questions at the end. But yeah, I'll hand over now to VLab, who will talk through the training module, which was delivered at Penrith, and this was a pole climbing module. So thank you very much for that.
Thank you, Paul. I'll share my screen now. So as Paul mentioned earlier, we have two sites, and the second one that we have worked on is Vibro Optics training grounds based out of Penrith in Cumbria. So they deal with working on telecommunication installation and maintenance of optical fiber cables across the UK. So to start off, what you're seeing here is a full 360-degree walkthrough of the Vibro Optics site. And this footage was captured using an Insta360 camera to show you the immersive view of the real world environment, the place where we are going tomorrow. The goal here is to show you exactly what the site looks like and the pose, the terrain, the kind of environment the workers will be operating in. and being able to visualize and replicate this in the virtual environment, in the virtual space, and to make the training feel more familiar and intuitive from day one. So what you're seeing here is the site. We have captured the site from different points to create a full 360-degree immersive view. Now we move into an early development. So compared to the other one, this was developed in a different game engine called Unity. And this is an early development stage of the virtual environment. So you'll notice that this is a simplified model. We are focusing here on like the layout, the basic interaction, rather than the full details. We went to web properties, got the feedback, and created much more interactive, interesting training skill-based training scenarios in there. So what you see here is what the trainees would see when wearing a VR headset. It's navigable, interactive, and we are just laying the groundwork for more advanced features in the future. So we have the hammer test in here just to see just to give a glimpse of what will be in the full model. Yeah, and next what we see is a sneak peek into multi-user interaction feature. I'll just pull up the video.
So what you're seeing right here is a virtual environment that is created based on scans from the training grounds of fiber optics in Penrith. And this is a virtual multi-user collaborative environment. We have logged in from different places using different headsets, so we can see everyone, each other, we can talk to each other, and we can collaborate in this area.
Okay, we should also say that each one of us is somewhat resembling the way we look like, because we try to use the photos to tailor, to customize the avatars, the avatar look. Now, some customization works better than other, but in principle, there are some functionality included to customize the way avatars appear. Okay, and then there are also some features which we can demonstrate, such as teleporting. So we can move from one site to another very quickly, not by walking. Obviously we can walk, but also we can use teleporting, and there's two options here to teleport. One is the interaction site, where it's possible to move objects, and the other one is the turbine site. So let's go maybe first to the interaction site. Can you all guys come, please? Great. So can you explain what you can do here?
So this is a place that we have created to demonstrate how interactions or training can be provided. So we just put this aside from the site. This can also be implemented inside the site as well. So in here we have these demonstrations. You can play around, see how the physics works, how the interactions works. There's this wind turbines. You can pick them up and put up in the wind, and it can rotate, and you can see everything, and you can play around with them. That's it.
Okay. And where can we go from here?
So from here we can go back to the site. We'll teleport back to the site, and then we can go and explore the top of the turbine. If we go to the edge of the site where we have placed the teleportation menu over here, go over there, teleport to the top of the turbine, and yeah. So there are also some interactions in here. The idea is to demonstrate that all these are possible to be incorporated in the training environment, in the multi-user meeting room. We are on the top of the tab right now. If you look down, you can see the interaction port over there, the Vibrotic site down there.
Okay, so it's possible to use this kind of training also to familiarize, for example, workers working on maintenance. That's the idea here. Or workers who are not only construction workers, but maybe from some other backgrounds. So it's a really a possibility to scale the applicability of this collaborative working environment. And everybody happy with everything?
So what you just see was a pre-recorded video of our multi-user interaction demo. So the idea about that is we were showcasing what's possible when multiple users, whether trainees or trainers, so multiple users inside the same virtual environment. They can communicate, collaborate on tasks, practice scenarios together, do anything that they want together. So this opens up a new door for team-based safety drills, remote monitoring, mentoring, peer learning. So even if the users are based on entirely different locations. And the next clip shows you our treadmill integration. So one of the biggest limitation and challenge in the VR when using a VR headset is physical space. You can only move so far in a room before you hit a wall or something. So treadmills help bypass that. So what we have, it allows users to physically walk while staying in one place. And that gives a much more realistic and we could say a spatially aware training experience. And this will help make the learning process with the which VR headset feel more natural, especially for the tasks that require a lot of walking, navigation, and so on. Next, we have our AR capabilities. I'll hand over to Ben to talk on this one.
Hi, can you hear me okay? Yeah, so VLab has also developed a simple app for AR-based identification of equipment used by trainees and operatives to identify and inform the user of the correct usage of each known object presented. This has the potential to save some time and improve health and safety during training and operations by reducing the time required by trainees to engage with training staff, as well as the incorrect use of tools and equipment. The example shown here includes basic hand tools and a short description of what the tool should be used for. However, this can be scaled up and tailored to task-specific equipment, such as in the case of fiber optics, fiber splicing machines. And one example that was given to me is the floor box lid removal tool, which kind of has a few nuances about how it's supposed to be used. And this would be a good way to be able to demonstrate that. It can also be used to present diagrams and external learning resources that can be attached for easy access to save time, both during training and whilst trainees are learning on the job. Thank you.
Thank you, Ben. We'll now go to the live demonstration. Hopefully you can see the screen. You can see my hands here. So this site was with the initial, what we say earlier in the video. We further developed the site based on requirements and feedback from the fiber optics team. So the first training that we have implemented here is like a PPE familiarization area. You have all of the PPE equipments, the best information regarding that, where the user can learn and get familiar with whatever all of the equipments that they will be using on site. So you have the information and picture of all the different type of vests. So the idea behind we have different type of vests is Vibra Optics has a policy that all the workers must be using a full sleeve vest. And we have the safety boots, you have the gloves, and all the equipments in here where the user can walk around and get familiar with. And just for an introductory, we have also provided some of the PP equipments where you can pick them up, you can see what they are, and just learn things, get familiar with that. And we also have provided like two people vests here. And once the user get familiar with all of these, they will be proceeding to the site, but the site is locked. So as you approach, you'll hear a voice. Hopefully your voice hearing that as well. So there was a voice. I hope you were able to hear that. So that basically we need to go back to the site and get the correct PPE vest and place that on the to get gain access to the site. So just to see if what happens when I choose the wrong vest. So when you put this wrong vest, you say you have to go back, and then it won't allow you access to the site. So once you enter the site, you will have another voice instruction coming forward for you to tell you what to do with the hammer test. So as instructed in the audio, you have got two hammers here. So once you pick up the wrong hammer, you get the voice saying that
a small inspection hammer is recommended. However, if you still want to proceed, strike the pole gently and listen carefully.
So when you pick up the wrong hammer, you get the voice instruction just as you heard now that that's the wrong hammer, and to pick up the right one, or you can still hear the voice, you can still go ahead if you want to choose this one. So if you can hear the voice, it's a rigid sound on the good pole, and if you go to the other side of the pole, you hear like a hollow type of sound, which resembles that pole is not safe for climbing. So as had in the instruction text, now if there is a bad pole, you need to report that that's guiding the users what to do in case if you come across a bad pole. And the next part of the training is you have also to assess if a pole is safe for climbing. The next part is you have a prodding test, You come over here, you have a button here which you could press, and that asks you to pull up the prodding tool, and that will give you audio instructions. So as we had in the instruction, we have got 2 poles here. One is, so the idea is if you go onto the bad pole and try prodding it, it will go in easily, just a little bit without no resistance. And a good pole will show no resistance at all. So just to try that out, if you put that in, that thing is going inside, and you have the text saying that there's no resistance, that means it's a bad pole. And if you go near this one, it shows a good pole. It won't go in at all. Now, the final part of the training is an evaluation. This is also a standardized test. This is just to show you what's capable. We have a couple of series of 5 questions, I believe. These questions are also part of CSCS test. So just to start, we have 2 kinds of question. Some questions have 2 answers. You need to answer both of them correctly to proceed. Some of them has only 1 answer. And based on how you answer these, based on your results, if you get all of them correct, you'll pass the evaluation. If you get some wrong, you have the option to you get a personalized repeating option where you only do the questions that you got wrong again. So I'll just go through it. As you can see, the question has multiple correct answers. You need to select both of them to proceed. When I select, you get an option saying one selected, choose one more to move forward. This question. This question is an example of having only 1 option, so you could just press any one of these. So, well, I failed, so you have the option to improve the fail areas only, and if you press that, you will get an you will have to answer only the questions that you failed. So that's like a more personalized way to relearn whatever you were not good at. Or if you prefer to have the whole test, if you prefer to take the whole test, you can also do that. So these are 4 parts that we implemented based on requirements and feedback from Vibro Optics when we went for testing. So yeah, that's all about this one, and we will go to the Q&A sessions. Thank you.
Thank you for that, Asar and Ben. So we are now at the point of the webinar where if anybody has any questions they wish to raise, we'd like to invite you to do so.